Now, in looking at this example, let's say I now want to create more squares that can handle different values, such as integers, floats, longs, because I want to be really precise with my math. That means I'm going to have to copy and paste this function, and I'm going to have to remember to change the return types and the parameter types of all of this, for example, for long. And I have to remember to change it here. And I have to remember to change it here. This could be prone to mistakes. What if I forget, for example, and make this an int? It might work for some values. We could test it, but we can see how this gets redundant if I want to do this for yet another type, for doubles or shorts or all the different types that we have. There must be a better way. And in fact, C++ gives us a tool. It's a really powerful tool. In some programming languages it's called generics, but in C++ the syntax is called a template. And a template allows us to parameterize the data types that we use. In this case, int, here in square. And the syntax for this is we type in template, and then open a left bracket, class, my type, close brace. And traditionally this is done on the line before the function, but it actually can read like this in one line, just as the whole function signature. I'm going to separate it out into two. It's a little bit more readable. Now, remember, my type is what's being parameterized. It's a variable for the type. So, in places that we want the type to match, we change it to my type. Whatever my type is that we return, we want to match with the result, which is here. And our variable that we're passing in, the type, is also going to be of the same thing. So if we want to use this template, how do we do that? There's one more syntax we need to do. We'll add the type here in the brackets. And that says, make sure that square uses int everywhere that my type is here. So everywhere we've typed my type, we want to make sure it's consistent. And we'll do the same for this function. We must pass the type in. Okay, so let's try to compile. No errors were made. We run. Same program as before. But let's see the power. Let's go ahead and add to our function. Let's do some data types that we didn't have before, such as double. And I'm going to say, do we need this? I believe we can get rid of the casting. Long. And we'll make this a big number. And let's try to run this. Here. Oops. Oh, looks like I added an extra left brace here. I will fix that. And make sure the left braces always match the right braces, or the right parentheses, excuse me. Compile. Run. And it looks like it's handling the different data types. Now, what happens if we do another data type? Because we've got all this power now. It looks like we have access to every single type that we want. But what if I want to pass in something like a string? Let's see what happens. Oh, looks like we get an error. Invalid operands to binary expression. So we can't have a binary expression that is a multiplication between two strings, because remember, my type here is a string. That's what it thinks the result is. And it's going to give us the error here, and it's going to tell us an instantiation of functional template specialization. That is the function template that we're using, square, with the template argument of string, isn't going to work. Okay, so we have to fix that. And in this case, it doesn't make sense to multiply strings, and we haven't taught C++ how to do that yet, so we can't do this. But any numeric expression where it makes sense to multiply, we can do that. If we want to have our own data types later, like a vector, in the terms of what's used in physics and linear algebra, then we can teach C++ about that, and again, take advantage of templates. Okay, so templates are a really powerful feature, and they're quite advanced and can be a little tricky to debug sometimes, but that doesn't mean to be afraid of them, because they really clean up our code, because now we only have one function here. And once you've written one template, you can sort of use this as a template, sort of pun intended, and use this as your framework for writing other functions if you'd like. If you think you might have a function that has different data types, that's when you use templates. But if you're just writing a one-off function like our hello function earlier, probably doesn't need a template. That might be a little bit too much. Okay, so we've learned about the basics of functions, the concept of function overloading, and function templates. We'll learn some more, but this is a great start. Some great exercises to try are things like writing the greatest common denominator function for that, an exponential function, a Fibonacci sequence function, factorial, or perhaps other mathematical functions, like computing is a squared plus b squared equal to c squared. See if you can write those functions as practice. All right, thank you.